today's video is about analyzing graphs of polynomial functions. And today I want to teach you how to be able to identify 7 different traits, features about polynomial functions. And here are my 7 questions that I want you to be able to answer. All right, question numbers 1 and 2 go together. They're about end behavior. And we're asking, is the leading coefficient positive and negative, and is the degree even or odd? First of all, I've got a left end and a right end going in separate directions. One of them is going to negative infinity on the left. The right end is going to positive infinity. So different directions for the end behavior would indicate that the degree is odd. Is the leading coefficient positive or negative? Well, here I'm going from negative to positive. That's an increasing function, and so we are going to say that that is a positive leading coefficient. How many real zeros does the polynomial have? The real zeros are the places where the polynomial crosses the x-axis. Those are zeros of the polynomial. So I've highlighted 3 of those points on the graph. There are 3 real zeros. What is the least degree that the polynomial function can have? Okay, well, since it has 3 zeros, it has to have a degree of at least 3. All right. Some of them are real. It might have imaginary, but it has to have at least 3 because 3 of them are real. All right, well, let's see if that's in keeping with the degree that we know is odd. All right, is 3 an odd number? Yes, it is. And so we're going to go with the number 3. Maybe it's bigger, but it's at least 3. Estimate the real zeros. Okay, I'm going to start from the one on the left. The one on the left is, well, it's got to be more than halfway between 0 and negative 1. Let's say that's about negative 0.6. All right, so we've got 1 0 at negative 0.6. All right, let's take a look at the one in the middle. The one in the middle looks like it's about at the origin, so let's say that that's 0. And then the one on the right is about halfway between 0 and 1. Let me say that's 0.5. The x-coordinates of those 3 zeros. Estimate the y-intercept. All right, I'm going to draw over that in blue. Again, we said that x equals 0 is about at the origin. All right, so the y-intercept is also 0. The coordinates are 0, 0 for the y-intercept. Estimate the local maximums and minimums. All right, so here in red, I've got a maximum, and here in green, I've got a minimum. They're not absolute maximums or minimums. The red point is not the absolute max because there are many points on the graph that are higher than it. The green is not the absolute min because there are many points on the graph that are lower than that. But we call them local maximums and minimums because the points that are near them, to the left and right, that one's the highest of the points that are directly near them. So let's say that the maximum, the local maximum, and we're estimating here, I'd say it's about x equals negative 0.4, and the a y-coordinate of about 0.5. The green one, the local minimum, I'm going to say x is about 0.4, positive 0.4, and y is about negative 0.5. Put my decimal point in the last problem. Okay. All right, so those are the 7 questions. We're moving on to problem 2. A new graph. Same 7 questions. All right, questions 1 and 2 about end behavior. Is the leading coefficient positive or negative? Is the degree even or odd? Here we've got both ends pointing up. So if both ends are pointing the same direction, then the degree is even. All right, is the leading coefficient positive or negative? Since both ends are pointing up, that indicates the leading coefficient is positive. How many real zeros does the polynomial have? I'm going to draw on the graph 2 of them. There are 2 places where the graph crosses the x-axis. Those are the real zeros. Number 4, what is the least degree that the function can have? Okay, so I want to take a look at the answer to question 3. How many real zeros does it have? All right, it has 2 real zeros. So the degree has to be 2 or more. If the degree of this polynomial was 2, it would be a quadratic equation, and its shape would be a parabola. This is not a parabola. So this graph has a degree that is greater than 2. It has to be even. And I'm going to point out something else about these zeros on the graph. It looks like they are both of multiplicity 2. Have we discussed that before in one of the previous videos? If a 0 crosses the x-axis, it's of multiplicity 1. If it only touches the x-axis but does not cross it, it has to be of multiplicity 2 or higher. And so we know that each of those zeros is a double root. And so this is going to be a polynomial of at least degree 4. It has to be even. It has to be greater than 2. We've got 2 zeros on the left root and 2 zeros on the right root. Estimate the real zeros. The one on the left is 1, 2 at negative 2. The one on the right is at positive 1. Estimate the y-intercept. There it is. All right, well, the x-coordinate is 0. The y-coordinate is 1, 2, 3, 4, about 4. Estimate the local maximums and minimums. Okay, well, the red 2 points, the 2 zeros, are minimums. So let's just write those 2 coordinates. We've got the local minimums at the 2 places where the zeros were, at negative 2, 0, and at positive 1, 0. The maximum, the local max, would be about there, the local maximum. What's the x-coordinate? It would be about negative 0.5. Negative 0.5. What's the y-coordinate? Let's see, 1, 2, 3, 4, 5. About positive 5. All right, last problem. New graph to analyze. All right, question number 1 and question number 2. Is the leading coefficient positive or negative? Is the degree even or odd? End behavior. Let's look at the ends. Down, down. They're both going in the same direction. That indicates an even degree. Now both are going down, so that makes a negative leading coefficient. How many real zeros does this have? Let's count them. It seems that there is one here and one here. There are 2 real zeros. What is the least degree that this function can have? Okay, well, it's even the degree. It has to be 2 or more. It can't be 2. It has to be more than 2, because if it were 2, it would be quadratic. So what this is going to tell you here, there is no multiplicity greater than 2 or 2 or greater, because it's not just touching the x-axis, it's going through the x-axis. But there are probably some imaginary zeros. The only ones we can see on the graph are the real zeros, but this polynomial probably has zeros that are have an I in them, have an imaginary number in them. All right, so back to the question, what is the least degree? It has to be even, and it has to be greater than 2. The next even number greater than 2 is 4. Estimate the real zeros. All right, so the one on the left, 1, 2, 3, 4, at about negative 4. The one on the right, 1, 2, 3. Maybe it's a little bit less than 3. Maybe it's about 2.9. Estimate the y-intercept. All right, well, the x-coordinate has to be 0. The y-coordinate would be about 0.2. And question 7, the maximums and the minimums. Maximum. There are 2 local maximums and 1 local minimum. The maximums, let's do the the coordinates of the one on the left, 1, 2, 3. That would be about negative 2.9, and then up 1, 2. Y-coordinate of about 2. The one on the right, we've got 1, 2, x-coordinate of 2, y-coordinate of about 1. And the local minimum, the x-coordinate would be about 0, the y-coordinate would be about 0.2. All right, so those are some examples of how to analyze graphs of polynomials. Do your homework.